Welcome back to another explainer. I'm absolutely thrilled you're here today because we're looking at something that is fundamentally driving the incredible leaps we're seeing in artificial intelligence right now. We are doing a digital unboxing of a massive Hugging Face repository, peeling back the layers to discover what actually makes a massive open-source AI model tick. We're skipping the high-level theory today and getting right into the raw underlying data structure. And honestly, spoiler alert, we're going to need a bigger hard drive for this one. Just to immediately ground us in the reality of what we're dealing with out of the gate, check out this number, 8.74 terabytes. I really want to emphasize that this is not just some simple folder of images you could casually fit on a standard laptop drive. This is an absolutely massive foundation for training artificial intelligence. To put that into perspective, 8.74 terabytes is roughly equivalent to streaming high-definition video continuously, nonstop, for over a year. It takes incredible engineering just to host, transfer, and parse this volume of data. Section 1. Meet the 50M Vision Corpus. Okay, let's dive into this. The specific repository we're unboxing today is the SenseNova Vision Corpus 50M, hosted over on Hugging Face. When we talk about vision corpuses, we're really talking about these vast visual libraries that teach machines how to essentially see and interpret the world around them. And before we start poking around in the actual files, it's always good practice to check the documentation, right? This repository is tied to a research paper with the archive ID 2607.0656D, which details the complex science behind the dataset. But equally important for anyone actually looking to use this stuff, it operates under a CC BY NC 4.0 open source license, meaning this incredible resource is available for non-commercial use, which allows researchers and hobbyists to experiment freely without massive corporate price tags holding them back. Section 2. Breaking down the specs. So, before we crack open the actual folders, let's read the label on the outside of our massive data box to understand exactly what's inside. Here are the core specifications of the dataset. I want you to notice that tasks category, any to any. This is huge. It means this dataset is designed to handle cross-modal tasks, basically translating between the modalities of image and text totally seamlessly. In practical terms, the AI isn't just looking at a picture of a dog, it's reading the word dog and perfectly mapping the two concepts together. Furthermore, to handle almost 9 terabytes efficiently, the data is stored in the Parquet format, which is a highly optimized columnar storage solution. And finally, the primary language for the text modality here is English. But seriously, how do you even open an 8 terabyte box without completely crashing your computer? Well, data is really only as good as your ability to manipulate it. Thankfully, this dataset is built to play incredibly nicely with the modern data science stack. Developers can easily jump in and manipulate it using familiar supported libraries like Hugging Face's own Datasets library, traditional pandas, or even the lightning-fast Polars library. Section 3. Inside the data folders. Now, what's really interesting about this is much of this directory structure was actually uploaded to Hugging Face just recently, meaning we are looking at some very fresh, cutting-edge organizational structures. The first major folder we encounter inside is called Dense Geometric Prediction. Now, this isn't just about telling an AI, hey, you're looking at a picture of a room. No, this directory indicates data structured to teach the AI highly detailed spatial awareness. It helps the model map the geometry of the physical world, understanding depth, angles, and spatial relationships densely across the entire image. This is exactly the kind of data an AI needs to, say, safely navigate a robot vacuum around your living room furniture, or eventually drive a car through a busy city street. Right after that, we find the multiview_visual_geometry directory, which builds perfectly on that last folder. If you want an AI to truly understand a 3D world, you can't just show it a single flat photo. Think of it like walking all the way around a sculpture in a museum to really take it in instead of just staring at a flat postcard of it from the gift shop. This folder contains data designed to provide multiple 2D perspectives of the exact same scene, which helps the models construct a really robust, multidimensional 3D understanding right inside their neural networks. Then we have the segmentation folder. In computer vision, segmentation is essentially the process of partitioning a digital image into multiple segments. This specific data folder provides the precise, pixel-perfect boundaries needed for an AI model to isolate, break down, and identify individual labeled regions or objects within a really busy visual scene. It's exactly how the AI learns where the bumper of a car ends and the pavement of the street begins. Rounding out our main folders is structure_view understanding. And what really stands out in this section is a very significant file pointing right to the sheer freshness of this dataset. Committed just 8 days ago, the SA1B Total Unified Visual Understanding.jsonl file is this massive text format where literally every line is a separate JSON object. Think of this file as a master key that ties all these geometric and textual concepts together. It's aimed at creating a total unified visual understanding for the model, which just goes to show how incredibly fast the open source AI space is moving right now. And this brilliantly illustrates the sheer physical reality of 8.74 terabytes of data. When you actually scroll down the repository, it just visually overwhelms you with this endless list of data chunks. Because the dataset is so massive, they had to use a split archive format. You've got file .tar.gz000 sitting at 21.5 gigabytes, .tar.gz001 at another 21.5 gigabytes, and it just continues sequentially all the way down to file 041. That is a staggering, mind-boggling amount of information to download and process locally. Section 4, the open source community. Massive datasets like this don't just magically maintain themselves. They require a dedicated human element. The open source village powering this Hugging Face repository is such a crucial part of the story. As of this explainer, there have been 79 total commits to the main branch of this repository. A commit is just a saved change, an update, or an addition to the code. So this number tells us that this isn't some abandoned project gathering dust. It shows active, ongoing development and refinement by the team behind it. And let me tell you, that team is small but mighty. There are exactly 4 contributors officially listed on the repository. It is genuinely incredible what a highly focused group of engineers can put out into the world. In fact, if we look at the recent activity, a contributor named Dink Wei Wong was actively making updates to the README and README_CN markdown files just 7 hours ago. Talk about fresh. And the broader community is certainly taking notice of all that hard work. The repository has already gathered 385 likes on Hugging Face. Now, sure, in the world of viral cat videos, that's nothing. But in the world of highly technical, specialized AI datasets, that is a massive indicator of community interest. It absolutely validates the extremely high value of what SenseNova has provided here. Section 5, why this data matters. So the crucial point is, why go through the trouble of hosting and processing nearly 9 terabytes of data in the first place? Because fusing any-to-any multimodal text and image learning on this unprecedented 8.74 terabyte scale is exactly the kind of thing that pushes AI forward. We aren't just teaching an AI to read or just teaching it to see in a vacuum. By combining text, images, segmentation, and that deep multi-view geometric understanding into one single, unified corpus, we are quite literally teaching machines to comprehend the spatial and contextual world in a way that's much closer to how we do. Which leaves us with this final thought. When you give open source developers, researchers, and hobbyists totally free access to the structured geometry, segmentation, and text relationships of 50 million images, what will they teach AI next? The foundation for that future is laid out right here in the SenseNova Vision Corpus. I really hope this explainer gave you a clear picture of the immense data structures that are powering tomorrow's technology. Keep learning, keep exploring, and I'll catch you on the next one.